There's this tricky issue of this thing that I need to current limit it, and that's for the amp, the fan out, maybe even the rectifier, the AND gate, even, yeah. And you want to power it all. Doesn't that mean you need a dummy AND gate that fires off as well? Yeah. Because it's always got to be using the same amount of power. Yeah, like if it doesn't go one way, it goes the other way, and then the power balances out. So that means I need a dummy AND. I need to times it all by 2, even the AND gate. And then I just got to distribute power of this current limit. So I just got 2 power supplies of equal current limit. And then I've got to distribute the power requirement to it all. And the whole thing is at limit constantly. That it's always at limit. I have to make it so it always uses the exact same amount of power for the whole freaking logic. And that's going to be a bitch, and I have to distribute it. And some bits need more current than others. And that means, yeah, not only does the amp need to have a dummy, so does the AND gate, so does the fan out. But I think fan outs are okay because they're always on. Not always. What if the value isn't on? What if that means you have to have the value was on and the value was off? Oh yeah, maybe that's what I do. I have the system and then I have the inverse system, and it's just got the inverse fucking values, and then it always uses the same amount of current. So I've got it's sort of about half the meter, then I've got the inverse mirror of the system, and that makes it so the current always adds up to the exact same amount. I think feedback is just an easy one if you can handle it. What do you think it is now? I think it's the same as the delay line, analog feedback. Except it's an analog delay line, except you don't worry about correcting it, you just send it through, and like whatever the amp reduction is, you just accept it. So there's a little amp loss it's drift to 0 if you do it like that. It will just slowly turns to 0. And then you probably could just have a ball booster. You tap the button and then it adds the value. If you don't want to do the assign reset, you probably just have ball boost, so you hold it down and then it slowly speeds up the ball. And then you have ball. Yeah, but if you wanted to have ball slow down, you have to divide it. If you want to have ball increase, you just send it diagonal. Send diagonal, and then you have ball decreaser, and then that divides it. So and that's a ring modder to divide it. It's a ring mod with a constant. AND gate should be able to do a divide as well. Yeah, so I've got to add ball center diagonal, and then decrease the ball speed if it goes too fast. And then the whole thing gets constant current of 2 current limited power supplies. So how are you going to distribute it? Well, it has to be done with resistors. And so I just have to look at something. Who knows what it is? But if I want twice the current here and half the current here, I can't just make that 1 and that one 2. This is the problem here. So if I make that 1 and 2, then that gets 33. That one gets 33%. Oh yeah, Mag, look. It is double. Oh no, you dummy. Yeah, in this case it is. Yeah, so, but if I add 4 and 8 to it, then what happens there is not double. Yeah, that gets like 50% of it, and then this gets the lower. Oh yeah. Oh, you know how to do it. It's just a DAC. It's a DAC, man. Oh yeah, so I don't know how to do it exactly, but I think. Oh yeah, it's just current divider, voltage divider. Same thing. I think it's just the same thing. It's just go down like that. It's just divided by 2 each time. It's kind of like a voltage divider. And that's getting 50%. To 1.5. Yeah. Yes. And it's all supposed to limit at the same time. It all has to limit at the same time. So it means that, so that means the resistance has to be perfect to the battery. Yeah. So you get the resistance 1 ohm. Then I've got to distribute 1 ohm to it all. So if I'm going 1 ohm and that's the resistance of the battery, then I have to equal, what is it? So like, well, that wouldn't be 1 ohm because there's extra ones. That's got to be more than 1 ohm. It's got to add up to 1 ohm in total. And it has to be an exact resistor. Taking into account all the pathways, I've got to add up to 1 ohm. Then I'm running on double A. And so I've got to do, so I have to be at exact limit for all parallel pathways. Yeah, that's going to be fucking tricky.